My name is Peter Timmler. I'm the Chief Technical Officer for Girder-Slab International. I wanted to start with the genesis of the Girder-Slab system. This was really spawned by a group of individuals, an engineer, a general contractor. Those three individuals were quite convinced that there had to be a better method of construction compared to a very conventional form of construction, cast-in-place concrete method, which inherently has many impediments to efficient build. And some of those impediments are the reliability on wasting time for strength gain, shoring having to be required on the project through false work, sometimes shoring post stripping of the false work as well too, and involving multiple trades. That can be a coordination issue. Certainly it is a heavier form of construction that leads to more expensive foundation work as well too. All of these, including the curing conditions, have to be controlled so that proper strength gain is made as well too. So all of these impediments really slow down the pace of construction at site. And these individuals were quite convinced that there had to be another method of construction that could eliminate these kinds of impediments. That's how the Girder-Slab system came to be, as an alternate method of construction to really cast-in-place concrete. The first challenge, however, was to ensure that a shallow floor plate profile could be developed, and this would be typically for residential spans. They wanted to ensure that there was plentiful supply of the construction materials, regardless of where you were in North America, and that the system would erect quickly. It would be beneficial to have a near-dry system as well, so that year-round construction could be employed with very little cost impact. And could it achieve the design flexibility, as you see in the photograph here, cantilevers, cutouts, setbacks, etc., so that there is versatility in the design that the teams would be challenged to produce. And that's how the Girder-Slab system was developed. A little bit about ourselves. We were founded back in 1997, so we've been around for 26 years. And we are a construction technology company. And the Girder-Slab system is just simply a more efficient steel-based framing system that captures the mid and high-rise residential construction. To date, we've completed about 300 projects, primarily in the US. We have a good following in Canada, but we are now doing projects abroad, in particular in India, Middle East, and now we are starting to enter into the Australian market as well too. We've done projects that range from 4 to 40 stories. We do have interest in projects that are even taller than that in major metropolitan areas in North America. Really what we cover are hotel projects, apartments, condominiums, mixed use, assisted living, student housing, but now we have branched into self-storage, correctional facilities, as well as some office spaces. The major statistic for us is that we have a very high percentage of repeat business. It's over 70% right now. And we find that once structural engineers and architects are aware of the Girder-Slab system, they've seen the results, they've seen how happy their clients are, that they continue to come back and utilize this system on future projects. Wanted to give you a sense of who we work with. Major engineering companies, major architectural firms, major developers, major general contractors and construction managers. So some of these names you're probably going to be familiar with. We've done, in some cases, multiple projects with these firms, and some of the clients that they service in the hotel industry basically cover almost every hotel chain that you can imagine. And we have a similar following on student housing projects. We've done many projects in the US. We're starting to do more in Canada as well too. And in some cases, we've done multiple projects at university sites, primarily because we are a reliable building method that guarantees that they do get the projects done on their tight schedules. Just a few words about the Girder-Slab advantage. Speed of construction is broken down more into a construction assembly rather than piecemeal development of the structure. And it's important to note that shoring is not required with our method of construction, thereby giving all of these follow-up trades easier access and unrestrained access to the floor plates for their service installation. Slim floor profile is a benefit when you compare it to conventional steel construction. We're eliminating wasted space on a floor-by-floor basis. This can save on the building skin costs on the project by lowering the height of the building, or if you take advantage of that lower height on the building required, you could actually gain more floors on the project for higher revenue generation. And that has certainly been the case on many of the projects that have utilized the Girder-Slab method of construction. Less labor is a major point as well too. The general contractors have less people to manage, less general conditions to worry about. Safety performance is improved and at a lower cost. This is a method of construction that can be utilized year-round. Certainly in colder weather climates, it's being taken advantage of so that they can complete projects many months earlier than weather-restricted forms of construction. And there's a very high probability if you stage your minor wet work, the grouting operation on better weather days, that you can eliminate all of the heating and hoarding costs that are generally carried in general conditions by the general contractor. Overall, this leads to an increased return on investment for the owners of the project. It's a faster completion. There's a reduced number of materials, coordination. This is a lighter structure than your cast in place method of construction, and certainly a reduced workforce. All of these benefits help with the increased return on investment. A few words on the Girder-Slab system. This is a shallow floor profile method of construction, and it relies on the chemical and mechanical bond between the steel, which is now a disymmetric section, the grout, and the plank. The steel framing and the hollow core plank are installed by just one trade, and that is the ironworkers. They basically have jurisdictional authority across North America for not only steel installation, but also precast installation on the floor plates of our projects. The heart of the system is the D-beam girder, and that is a fabricated element that is virtually done by any fabricator that has the capability to cut the pattern from a standard wide flange shape. Once that pattern is cut, two identical castellated T's are basically formed, and each of those T's are used to produce two D-beam girders by welding a narrower but a thicker top flange to the web. There is zero waste in the production process, and is a simple manufacturing process that essentially every fabricator is capable of doing. A little bit about the composite behavior. This is a very effective composite system. If you look at detail S1, you will see that rebar is passed through the web of the D-beam, and that is grouted in place into the hollow core on either side. And once that is set, you can have very reliable composite behavior with the steel and the concrete and grout working together. We have two family sizes of D-beams, an 8-inch series or a 9-inch series, and those are interchangeable with either 10-inch or 8-inch hollow core plank. There is provision for chopping, and that is a variable up to the design and construct team. It is not necessary for the composite design behavior of the D-beam, and it is a variable as in many cases up to 2 inches. You can use a lightweight leveling compound, you can use a normal weight or a lightweight topping, but we see designs varying from 3/8 of an inch to 2 inches typically. The first is really fire resistance. Now, there are 2 methods of fire protection that are typically utilized by this listing. The first is cementitious spray just to the bottom flange of the D-beam, and that's because the rest of the D-beam is obviously encased in grout. The second method is to box the bottom flange with gypsum board if it is in an exposed area, fitting area. Now, there are 2 other exceptions or alternates to that. If you're doing a high-end that is requiring a drywall finish ceiling and your D-beam is in that living space, if you run your drywall past the bottom flange of the D-beam, you're going to automatically get the same enclosure rating and therefore have a 2-hour fire rating for that condition as well. So no additional fire protection is required on the bottom flange of the D-beam because it is part of your finish. The same goes for projects that have architects specifying fire-rated walls. If the D-beam is within that fire-rated wall, it does not have to have any additional fire protection. 4 to 4